Now we're on part 11, page 421, and we finished up the neurotransmitters, and we're going to learn a little bit about neural integration. Okay, so that means that we're going to be putting things together. Let's take a look here at this. Here we have a single neuron reaching down with a multiplicity of branching axon terminals. Notice that in some cases we're actually going to be creating synapses of 1, 2, maybe 3, 4, 5 on one neuron over here. Over here we might only get 1. Over here only 1. Over here maybe 3. Over here maybe 4. Right, so the idea here is that when we create a whole bunch of synapses in this more central pathway, that this becomes the discharge zone, while this becomes facilitated over here. Okay, so you can see that depending on how you arrange your circuitry, if you fire off on one or two of these initiating neurons, you might get certain kinds of results that are more likely. And so we're looking at the neuronal pool here. That's the deal. Then we have various types of patterns of neural processing that we have to consider. And so let's take a look here at what's going on. They give us some examples here. So I think we should actually begin with the combination of either serial or parallel processing. Let's begin with that. Okay, so serial processing is when you start someplace, every time it's the beginning someplace and you get to the end of it. When we memorize poems or other aphorisms and that sort of thing, oftentimes are in memory because we're dealing with a particular sequence of words and sentences. We serially process. Our initial exposure to most information we take in a serial processing type of way. Right, so we learn, we repeat, we rehearse the thought process, and there's a beginning, there's premises, and there's conclusions that we come to, and it's a serial processing. It's sort of like it's difficult if you've learned as a child the pledge to the flag and that kind of thing, it's impossible or difficult to start in the middle. You have to start at the beginning. You can't go backwards. It's happening 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It's in a particular order. However, if you become really familiar with the territory, then you can start parallel processing. And once you become really familiar, I remember when I couldn't get lost anymore in Golden Gate Park, it was almost a sorrowful moment because I sort of enjoyed the adventures that I used to have walking through Golden Gate Park, and then at a certain point I had so many walks that I could start anywhere and I knew where I was. But the deal is parallel processing then is a deeper type of experience where you can arrive by many pathways to the same conclusion. Looks like a duck, walks like a duck, quacks like a duck, must be a duck kind of idea here. So there's that sensibility. Then we have very specific kinds of circuits. So in this example is I've decided I want to run, and I'm starting from stillness, and then I'm creating a pathway of amplification. So starting to run would be the example here, is where we're actually amplifying an initial circuitry activity. Amplification, that's what this is. Then we go the exact opposite ways. We go from many different inputs and we arrive oftentimes at the same conclusion. And so there's many things about a loved one that will remind us of that person. Besides a picture of their face, you might also see an article of clothing. You might also smell a particular scent which you associate with that person. You might be reminded by one of the objects that's common in their life. If they're a person who likes a particular sport, and you notice that that's their soccer ball over there, or their baseball glove, or whatever. Thanksgiving is a similar situation where You remember it by many different devices, from turkey and football, or the cooking of food, preparation in general, the smells and scents of a household, the coming together of many people, traveling distances to get together, to be with one another as a family at the time of Thanksgiving. So there's many events that converge. So this is a converging. So this would be a diverging or an amplifying circuit. This would be a converging or a concentrating circuit. This one is something that we refer to as reverberating, and it happens when we're breathing. It happens when we're walking. It happens during the sleep-wake cycle over the period of a day. So there's oscillations that are regulated, and there's a feedback system here, a reverberation, that allows you to do things over and over again in a similar way. Then we have our parallel processing that I described before, usually involved in investigations, right? So if you want to sort of note that this is the destination, this is the object of your research over here, you might get to it by a variety of different methodologies. Okay, so exacting mental processing, you test a number of different theories and see if you get arriving at the same result each time. I think I call that proofs. That's where the walk like a duck, quack like a duck, look like a duck, all this kind of different things like that. Okay, so, and that completes our process here of neural circuitry.